Hello everyone, my name is Wei Zhang. I'm from Alibaba Cloud Container Service team. Today I'm glad to share Serverless Kubernetes. It will include Serverless container introduction, the architecture, and several common use cases. Okay, let's start. The first part is the introduction of Serverless container. Nowadays, everyone talk about service in public cloud. We all know the function computing like AWS's Lambda. We can see that developers love service mostly. The reason of that is I think is service make developer the life be much easier. We think the reason contains three aspects. The first is the engine development. In service way, developers don't need to purchase service, no need to provision service, no need to manage backend service. All need to do is just one run workload, and they don't need to upgrade operating system and system software. We can saw that the productivity is become much high, and the time to market of the application is much shorter. The second reason is scaling. We think in service way, the scaling is inherently scalable. Application built on with service infrastructure will scale automatically as the user grows and usage increase. From a developer point of view, the capacity can be unlimited. So scaling in service architecture is much simple. The third reason is cost saving. In service architecture, there is no need to maintain fixed resource pool. It's pay by demand. Charges start when workload start, charges end when workload ends. We will never pay for the idle resource. We found cost may saving up by 70% when we change the application architecture to service. In this section, our topic is service container. Service container is one kind of service architecture. It have all advantages of service architecture, engine development, easy to scale, and cost saving. Besides of these advantages, it's based on container, not function or any other form. Container make our application build once and run anywhere. There is no limitation on language and library. We can choose whatever language or library we want to build our application. And the most important part is the ecosystem. The whole cloud native and Kubernetes ecosystem is built on container. We can benefit from enormous Helm charts, Istio Knative, and many other Kubernetes framework. We don't need to worry about a vendor lock-in because all this is built on top of containers. Today, most all public cloud providers have its own service container service available. This is the product landscape of public cloud. In service container catalog, Alibaba Cloud has service Kubernetes and elastic container instance. AWS have Fargate, and based on Fargate, they have EKS on Fargate and ECS on Fargate. Azure has ACI, Azure Container Instance. Next, we will deep dive into our service container products, ECI, ACK on ECI, and ASK. ECI means Elastic Container Instance. It simply means we can create a container without managing loads and infrastructure. Before ECI, we have to purchase a ECS virtual machine to deploy a container. With ECI, no ECS purchasing and provision is needed. A container is the first-class citizen in public cloud. Each ECI is completely isolated, runs in a sandbox execution environment. The CPU is ranged from 25 to 64, and the support GPU instance. All this is paid by on demand. Using spot instance, we can save cost mostly by 19%. ECI startup time is about 10 seconds. With image cache, image pooling time also can be saved. It was to mind that ECI and ECS share the same ICE resource pool. This can guarantee the enough underlying resources provided to ECI users. Standalone ECI is just like a single pod in Kubernetes cluster. If we want to use deployment with multiple replicas or stateful set or jobs or cron jobs, we shall use Kubernetes on ECI. At Alibaba Cloud, based on ECI, we have flexible ways to connect Kubernetes with ECI. The first one is use ECI pod in classic Kubernetes cluster. The second one is Serverless Kubernetes. We call it as ASK. In ASK cluster, all pod is ECI instance. There is no node needed to manage. It's complete nodeless architecture. In ACK on ECI architecture, normal pod and ECI coexist in one cluster. Normally, user can put a non-run workload on ECS node and put a short-run or scaled workload on ECI. This way can optimize total cost efficiently. The Kubernetes cluster capacity is determined by the number of nodes in cluster. By adding ECI into cluster, the capacity of cluster becomes unlimited. It makes scaling be much more easier because users don't need to worry about the capacity planning. In this kind of hybrid cluster, ECI pod and ECS pod can be interconnected. It means ECI it is easy to communicate with ECS pod. It also supports cluster IP service. In this way, ECI pod is just like a normal pod. In Serverless Kubernetes cluster, they have no node need to manage. User can just run the container application without managing the infrastructure. It's quite easy to use. In ASK, we will never see the common issue of nodes. For example, node not ready is not exist in ASK cluster. In other way, ASK make Kubernetes much easier for end user. The scaling in ASK is very fast based on ECI. It is compatible with the Kubernetes API like deployment, stateful set, job, service, ingress, and CID, and any other operators. We can also install Helm chart. The pod can be mounted disk, NAS, or OSS worms. In ASK, we provide kitative serving and elastic workload functionalities. We will expand this more later. ASK also integrated well with ARMS and SLS products. It's easy to monitor the pod and dump the pod logs into SLS. This is the architecture of Serverless Kubernetes. As we can see, the central part is ASK scheduler. It is responsible for watch pod changes and then schedule the pod by calling ECI API to create an ECI instance. Then ASK scheduler sync the ECI instance status back to pod. Using this nodeless architecture, we separated Kubernetes layer and ECI resource layer. This makes it ideal for elastic scaling in public cloud. In the next part, we will show some basic functionalities to use the ECI pod in Serverless Kubernetes. It's quite easy to create a GPU instance. GPU driver is pre-installed, such as TensorFlow and CUDA toolkit. We can just configure the GPU spec in annotation and the number of GPU then the GPU instance is created. ECI GPU instance share the same specs as ECS GPU. Spot instance is normally called a permittable instance. It means the pod can be permittable after 1 hour execution time based on a stock situation. Spot instance can minimize the cost in many scenarios, such as big data, image and media coding, science computing, scalable website and test, same as ECS spot instance. We both spot as price goal and spot with price limit strategy. With elastic workload, we can manage the replicas distribution of ECI on-demand and spot instance in one deployment. This can save cost for deployment or stateful set workload. In this YAM example, deployment engines will have 2 replicas runs in normal ECI on-demand, and the rest 4 replicas runs as spot ECI. Recently, SK have managed kitative serving functionality. It provides automatic scanning. When the pod have low traffic, it will scale the minimal instance with lowest cost. When traffic becomes normal, pod will scale to normal instance. A more kitative serving functionality is also supported in SK. Okay, the final part, that we see some common use case of serverless Kubernetes. Weibo is the largest social media company in China. It's just like Twitter in United States. It could have unpredictable hot events which bring hundreds of times of traffic in a short period of time. In order to handle this kind of peak traffic, using ECS scanning normally at least needs 5 limits, but using SK and ECI, Weibo reduced the scanning time by 70%. It can scale 1,000 pods in 1 minute and scale to 0 when there is low traffic. Similarly with Weibo, many e-commerce and online education companies use SK on ECI to handle peak traffic. When peak traffic comes, just scale workload on ECI, so there is no need to maintain large amounts of ECS loads in Kubernetes cluster. Big data computing is also a common use case for SK. We can schedule Spark work jobs on ECI. There is no need to vary the cluster capacity by this way. Today, many users use SK for CI/CD pipeline, use schedule Jenkins and GitLab run jobs in SK cluster. The total cost is much lower than using a classic Kubernetes cluster because the job is paid for on demand, not the loads. Okay, here I have some links for quick start. Try SK and ECI is very simple. Just need 2 steps. First is create a Serverless Kubernetes cluster. Second is create pod in that cluster. Okay, this is all my slides of this section. Welcome to try Serverless Container and the Serverless Kubernetes in Alibaba Cloud. Hello everyone. Here is a demo of Serverless Kubernetes. In this demo, we will show how to create a Serverless cluster and show how to create a pod in Serverless cluster. This is our ACK container. We can create a normal ACK cluster in this web container. Also, we can create a service cluster in here. Create a service cluster is very simple. First, we give a name. We just name it service. We choose a region. The next is we choose Kubernetes version. And next is VPC. We can create a new VPC or use existing VPC. we choose the zone. Let gateway means when we enable let gateway, we can let our pod access public internet from that gateway. So if our pod, there is no need to access internet, we just disable this one. Public access means if we want to access the web API server from internet, so we need to expose the API server with the EIP. The private zone means service discovery in cluster. It's just similar with CoreDNS in ACK cluster. If we just run a simple job, there is no need to use service discovery. So we also don't need a private zone in here. Okay, then we agree the terms. The next is create a cluster. So as we can see, create a service cluster is very simple. There is no need to purchasing or provision any nodes or works. They just give a name, choose region, and create a cluster. Okay, so it will take about 1 minute or less time to create a service cluster. And it was to mind that service cluster can be totally free. There is no charge or fee if we don't choose enable let gateway or public access. So it's totally free. It only charges when we create a pod in service cluster. Okay, let's get back. Which is initialize status. We won't wait for this service cluster. We just use a existing 100 region ACK cluster. We can copy the kubectl into SSH terminal. As we can see, in this service cluster, there is no node. So it's different with normal Kubernetes cluster. In normal Kubernetes cluster, they must have a node before running any pod. So, but in service cluster, we just run our pod. We don't need to care about the underlying nodes. The first demo is just let's run a simple YAML file. In this YAML file, it contains a service and a deployment. The replicas of this deployment is 2, and it's quite simple. It's just an index image. Apply it. Okay. Get pod. As you can see, the pod is assigned to a virtual Kubernetes node. It becomes running status. Another is pending. Okay, both is become running, and we check the nodes again. Currently, they have one virtual Kubernetes node. So this backseat shows us we first have pod, then they have a virtual node. Let's get a service. We create. Okay, this is quite a simple demo. Let me delete it. No. Okay, we then can scale this deployment. We scale to 10. Okay, we also can check this pod in web console. And here we get into the cluster and check the workload. The pods all become running. They have 2 loads in this cluster. Okay, we will clean up the resources. The next demo is Spot instance. Let's check. The YAML file is still very simple. It is a deployment with replicas 2, and we set the specs is 2 and 4 GB. We use Spot strategy as a price goal. It means we don't set the price limits, so it's a total price as market flows. Okay, the 2 replicas is become running. Actually, this 2 pod instance is Spot instance is not on demand. So basically, the cost of this Spot instance is very low. So Spot instance, we suggest it can be used in many scenarios like jobs, CI/CD, or Spark, Presto, or big data computing in many cases. The next demo is we can install a Helm chart. We just call Elastic workload. I just create it. It's very simple. Okay, I have we need to clean it. Okay, let's quit again. The Elastic workload controller is in pending status. So it's becoming running. Okay. Then we will create an Elastic workload object in this cluster. Let us first check the YAML file. In this YAML file, it's very simple. First is a basic deployment definition. It is quite normal, and we define a new Elastic workload object. It have reference to the engine's deployment. The minimal replicas is 0 and the maximal is 2, and the total Elastic workload replicas is 6. And they have a Elastic unit, ECI Spot. In this unit, all pods have a rotation with Spot as price goal. It means in this Elastic unit, all pod is Spot, and they have a basic 2 replicas is normal ECI pod. Let's create it. Okay. Let's clean up before Nginx Spot. As we can see, they have 2 ECI normal pod and 4 ECI Spot instance. We can scale the Elastic workload. We can scale it scale elastic workload to 10. Okay, the Spot instance have 8 replicas. We can scale down to 1. Okay, it's just one normal ECI pod. We scale back to 6. Okay, they have 4 ECI Spot. This is a demo of elastic workload. Besides of these demos, we can also easily to run Spark jobs in service cluster. The Helm chart installation is very simple. Okay, sorry. We logged in again. We change it to English. We quit again. After we install Spark Helm chart, we can create Spark jobs like this one. Okay. Back to our console. This is a demo of Service Kubernetes cluster. As you can see, it's quite simple, and welcome to try it. Thank you for the time to watch this demo. Thank you.